Okay, we're live. That was pretty fast. Just let the Discord know, of course. So we're gonna finish the Docker stuff because I didn't get a chance to finish it yesterday. Kind of got a little distracted. So yeah, that's kind of what we're gonna be doing. And hopefully finishing this off. I don't know if we will, but you know, that's the aim at least. Yeah, okay, so that terminal does show up. Cool. So yo, how's it going, Vaynor? Welcome, welcome. So let's begin. So last we left off, I think we were using the build cache. This was the lesson that we needed to start. So cool. When you run the Docker build command to create the new image, Docker executes each instruction in your Docker file, creating a layer for each command. Oh, interesting. When building a new image with Docker build, actually gonna put this in its own section. Building. Yo, how's it going, Codex? How's it going, Zaddy? Edits, welcome, welcome. Yo, Satyam, welcome. What was this called? Build cache. Using the build cache. Okay. Might make this like a subheading or something. Cool. Docker executes each instruction, creating a layer. Docker creates a layer for each instruction in the Docker file in the order specified. For each instruction, Docker checks whether it can be reuse the instruction from a previous build. Ah, I see. So for when building, actually, hold on. But Docker checks if it can reuse the result of a command from a previous build, which would be like a cache, right? So, yeah. So that's kind of cool. Docker checks whether it can reuse the instruction from a previous build. It finds that you've already executed a similar instruction. Docker doesn't need to redo it. Nice. This way your build processes become faster and more efficient. Using the build cache. I guess that's like automatic, right? Am I going to containerize my backend? At the very least, the database. That's the goal, is I'm going to containerize the database. Whether or not I go crazy and containerize everything, I don't know yet, but at least the database for sure. Also, you may see above me that I have like a supporter goal. I don't even know if that works or not. For like channel memberships, it says 0, but that's not technically not true. I'm just trying out Stream Elements widgets. So I genuinely don't know whether it's going to work or not. So we'll find out, I guess, or not. But I just wanted to kind of make that aware, I guess, or make that known. Okay, so using the build cache effectively lets you achieve faster builds by reusing results from previous builds. Yeah. So this helps with build times and skips repeated work. Yeah. Any changes to the command of a run instruction invalidates that layer. Docker detects the change and validates the build cache. Ah, I see, okay. So how the build cache may become invalidated. Changes to run for a layer for an instruction, or at an instruction. Any changes to files copied into the image? Any changes to files copied into image with copy or add? Docker keeps an eye on any alterations to your files. Whether it's a change in content or properties like permissions, Docker considers these modifications as triggers to invalidate. Once one layer is invalidated, all following layers are invalidated. Yeah, that makes sense. Layer invalidation cascades in the sense that if that when a layer is invalidated, all layers above it are also invalidated, which makes sense because if you make a change to layer 2, say you add a dependency to like a node image or something like that, then that dependency might be used by the subsequent layers, right? So you've got like node as your base layer as an example. Actually, let's backtrack. Let's say you have like, I don't know, some Linux distribution as your base, and then you have node on top of that, and then you've got like dependencies, right? So if you change dependencies or add a dependency, and then you have apps that sit on top of that require those new dependencies, of course you have to invalidate those apps, or the layer that builds those apps on top of the layer with the dependencies, because it might need those. So that all makes good sense. Whether you're writing or editing a Docker file, keep an eye out for unnecessary cache misses to ensure that builds run as fast and efficiently as possible. Yeah, that's fair. I would imagine this process, especially with large images, can get pretty cumbersome. All right, try it out. In this hands-on guide, you will learn how to use the Docker build cache effectively. Is this the to-do list app? Is this the same one? Bro, we've cloned the shit out of this app. Oh, it's a fork of the getting started app. Okay. I don't think it's the same one. Let's see. Can you see the terminal? Yes, you can. Okay. So oh wait, that's the wrong spot. I forgot to navigate. RMRF. I forgot to navigate to web projects, Docker. There we go. Now I can clone it. All right, inside this directory, you'll find a file named Dockerfile with the following content. So if we do cat Dockerfile, then you can see that matches. Execute the following command to build the image. All right, and then so it'll probably say some like lengthy amount of time because we're building this for the first time, right? Okay, so I don't know how long that took. I think it was like 3 seconds or something, right? And then now if we build it again, it should be much faster. Yeah, see, that was like way faster. Does it even say like, oh, that's not what I wanted to do. I did not mean to paste all that. I don't even know how that happened. What the shit? Okay, there we go. Okay, but I think that you can see that it's cached. So if we do that again, Docker build, you'd see cache Docker image. Yes, so that's good. And then you can see cache for all of these as well. So these are the different layers, I would assume, right? So you've got like layer 1 out of 4, layer 2 out of 4, 3 out of 4, 4 out of 4, right? And that's for like each instruction, which is good. Subsequent build was completed in just 1 second. Yeah. Going back to the Docker image history output, you'll see that each command in the Docker file becomes a new layer. Yes. Oh. Docker image history, and then this image? Or was there even a name for it? I guess I have to give it a name, right? So would it be this one? Yeah. Okay, so you can see that each one's a layer, I guess. You might remember that when you made a change to the image, the yarn dependencies had to be reinstalled. Is there a way to fix this? It doesn't make much sense to reinstall the same dependencies every time you build. To fix this, restructure your Docker file so that dependency cache remains valid unless it really needs to be invalidated. Okay, because that makes sense. Because you could cache all the dependencies except for the new ones or the ones that were deleted, right? For node-based applications, dependencies are defined in the package JSON file. I see. So start by copying only that file first, and then install the dependencies. Okay, I see. So we can make that change. So instead of so before this run, then we'll put the copy down here, right? And then we can do copy package JSON and yarn lock into the root, or the current directory, I should say. Okay. And then a docker ignore, which I would imagine, is pretty analogous to git ignore, right? So then we can, create that. Then we'll do node modules. Okay, so now it's changing because we changed the command, right? So you'll see we're copying the package JSON first, which then when you do this, won't need to reinstall the dependencies that are already defined inside of here, right? So when we copy the package JSON first and then run, it's only going to run this if the package JSON changed, right? But then so now we've cached this, right? And then if we do this again, it'll be like way faster, right? As you can see, it cached for every layer, right? Because we didn't make any changes. Docker build -t node app 3.0. Okay. And then this, I think this brings us into a terminal, right? Or never mind. Or is that for tagging? That might be for tagging. What was the -t again? It was the tag flag. Okay. That is right. Okay, cool. Okay. So first off, you should notice that the build was much faster. You see that several steps are using previously cached layers. Very cool. All right, multi-stage builds. In a traditional build, all build instructions are executed in sequence and in a single build container. All those layers end up in the final image, but it can lead to bulky images. Okay. Multi-stage builds introduce multiple stages in your Docker file, each with a specific purpose. Think of it as like the ability to run different parts of a build in multiple different environments concurrently. I see, okay. So it's kind of like a distribution of load. By separating the build environment from the final runtime environment, you can significantly reduce the image size and attack surface. Interesting. Allows for the ability to run different parts of the Docker build in different environments concurrently, which reduces the image size and attack surface. And attack surface being like the amount of ways that the image can be like, like attacked, I guess, or is vulnerable. Right. The attack surface of a software environment is the sum of the different points which an unauthorized user can try to enter data to extract data from or control a device. Okay, so that makes sense. I kind of thought that's what that was. Okay. Multi-stage builds are recommended for all types of applications. For interpreted languages, you can build and minify your code in one stage. For compiled languages, multi-stage builds let you compile in one stage and copy the compiled binaries and do a final runtime. I see, okay. Okay, so then defined by multiple from statements. Each is its own stage. And then you can also include to name stages. Cool. The Docker file uses two stages. The build stage uses a base image containing build tools needed to compile the application. It includes the commands to install build tools, copy source code, and then the final stage uses a smaller base image suitable for running your application. Copies the compiled artifacts from the build stage. I see, okay. Because you don't need to necessarily include all of that in one stage, right? Because you can build it and then kind of transfer the built stuff to the runtime. Which, you know, if it's just runtime stuff, that's doesn't need to be built in that same stage, which makes sense. Finally, it defines the runtime configuration for starting your application. I see, okay. Open this pre-initialized project. How do I do that? Spring Initializer is a generator for Spring projects. It provides an extensible API to generate JVM-based projects with implementations for several common concepts. Okay. Okay, so I can just press generate, right? Because it's got all the examples. Okay. Okay, and then I need to put this inside of, let's put it inside of Docker here. Oh, it's a zip, of course, okay. So we're gonna have to extract that. There we go. Very cool. Navigate to the project directory. Okay. Let's make sure that works. Okay. Navigate to, once you unzip the file, you see the following project directory structure. Yeah, so we have our help, MVNW. I don't know what any of this is. I've never, I don't use Java for building stuff, so this is kind of new to me. Okay. Once you unzip the file, you see the following. Okay. The source main Java directory contains your project source code. The source test Java directory contains the test source code, and the pom.xml is your project's project object model. Okay, I don't understand any of this stuff. It's a single configuration that contains most of the information needed to build a customized project. I see, okay. Okay, 4, create RESTful web service that displays hello world. Under source main Java com example Spring Boot Docker directory, you can modify your Spring Boot Docker application.java file with the following content. Okay. So this is just like a backend, like Java backend. That's interesting. Okay. Source main Java com example. This is the other thing too with Java that I've noticed is like the amount of like subdirectories inside Java projects is insane. Like, I don't know. I know this is not, you know, just the Java stuff, but like that's one thing I noticed when I used it in school, the little bit that I did. Okay, and then now we can Vim Spring Boot Docker application. Okay, so let's just edit this in Vim. So what do I need to add to this? Okay, so there's a lot more lines here. Okay. I don't remember how to copy from clipboard in Vim, so I'm just gonna type everything. Spring application, auto configure Spring Boot application. Okay, so then import org Spring framework web bind annotation request mapping and REST controller. And then I forget how to duplicate a line. Let's look this up real quick. Okay, so I think it's, okay, so we can do YY and then P. There we go. Very nice. Okay, and then this needs to be REST controller. Spring Boot Docker application. Okay, so we're just using the API here to send, oh wait, this is a tag. Public string home. This is a really weird way of doing this. Turn hello world. Okay, so then we're just kind of putting the, I don't know if this needs to be entered or not. We're kind of mapping this public function to return hello world to the root of the API, right? Very neat. Okay. Spring Boot Docker application file starts by declaring your com example Spring Boot Docker package and importing necessary Spring frameworks. This Java file creates a simple Spring Boot web application that responds with hello world when a user visits the homepage. Yeah, that makes sense. Okay. Okay, so we need to go back to the web projects Docker, Spring Boot Docker. And then in the Docker file, do we even have one? No, we don't. Okay. So this is our base image. So Eclipse is not, is that not the, Eclipse is an IDE though, isn't it? What even is that? Eclipse, open JDK binaries. Oh, okay, I see. So it's just like the Java development stuff. Okay. Provides code and processes that support the building of runtime binaries and associated technologies that are high performance. Okay. Okay, so it's basically just like an environment for Java, like a Java runtime. Okay, that like akin to Node, right? How Node is a JavaScript runtime. That's the Java runtime. That's my understanding. Okay. Define the work directory. This will specify where future commands will run. Although I don't think I have the app directory in the, I don't think it's actually in there, but that's okay. Copy both the Maven wrapper script and your project's pom.xml into the current working directory. Okay. MV and W into and pom into just a directory. Run MV and W. Maven wrapper, that's what it is. Okay, so Maven wrapper to download all the dependencies for your project. Okay, so this is kind of like the is it a package manager? What is it then? What is Maven? I don't really need to understand all this, but I want to. Oh, that is not what I want. Apache Maven, this is it. Oh, it's a build tool, okay. Manages a project's compilation, testing, and documentation. Okay, so it's more than just that. All right. Interesting. Okay. I'll kind of take it at face value. And then let's just finish this off. So we're going to copy our source to the application, app/source, and then run this command to execute the build process from Maven. Okay. Very nice. But this isn't like multiple stages. I guess we're getting there. Okay. Okay. See how long this takes to build. Okay, so it's downloading dependencies. So it's kind of like, I would assume it's like a package manager and a build tool in one, maybe? I don't know. That's kind of my understanding. So anyway. Yeah, so building 26 seconds, 27 seconds, 28 seconds, 29, 30 seconds. Okay, so it took 30 seconds to build that, right? And then we could check the size of it as well. So that is what? 303 megabytes? That's pretty big. Or would it be disk usage? I guess it would be disk usage. 886. Very nice. All right, I'll leave this next section to after the break here. Break, quote unquote. But anyway, I hope all of you guys are having a good start to your weekend. You know, it's pretty chill. I wonder if this other chat element, okay, no. Did you have to sneeze? Oh. You can just sneeze. Yo, good morning, Blue Core. Welcome, welcome. It's good evening here, but I recognize that it could be any time, anywhere in the world, depending on where you are. So, yeah, I know the evening streams aren't really convenient for a lot of folks in Asia and stuff because it's kind of like really early morning. But you know, I can only stream when I can stream, I suppose. Tomorrow I'm going to be doing an afternoon stream though, so that'll be like late evening over there probably. So how's my learning so far? It's pretty good. I'm kind of hoping that this stream will be like a lock-in stream. I want to finish learning Docker. I've spent, I don't know, a few hours, you know, learning the basics, going through the documentation, and then after that, I want to start another full stack project, but using Docker containers for, at the very least, the database, but maybe I'll containerize the entire application. I'm not sure. Like in separate containers, right? Because I have, you know, the front end, the back end, the database, those sorts of things, right? Actually, I think those are really it. But again, like, I don't know if you were around for this, but I made my own stack, partially just to understand, well, actually, really mostly just to understand, like, you know, each element of full stack development, so that I could kind of have kind of a clear view of what's going on. Because I find that things like full stack frameworks, like whether it's Next.js or TanStack or whatever it is, it kind of abstracts those concepts between front end and back end, and the whole thing becomes kind of difficult to keep track of if you're a beginner. I'll just put it that way. So you know, ran into some you know issues there, but you know, so that's why I'm taking this approach. Okay, so let's continue. Docker run on 8080. Very cool. And then now it should just work, right? Oh, because that Docker image is still running on that port. Oops. Hold on. I gotta, like, can I kill this? How do I kill the process? Hold on. Okay, I did kill it. All right. So I gotta run it on 8081. Maybe. Good luck. I appreciate that, Blue Core. All right. Now maybe this works. Maybe not. Or do I have to curl it? Because I feel like it would just show up in the browser, no? I don't know, man. New tab. Let's zoom in a little more. And then we'll do connection reset by peer. Okay. What Docker containers are currently running? Oh, Spring Hello World. Okay. 8081. Okay, so it should be on that port. I don't know. Of course, it wouldn't be on 8080 still because I changed it. Oh, yeah. I don't know. Does it say? Start on port 8080. Okay, it did. It was 8080. Okay. Docker stop Spring Hello World. No such container, really? I think there should be. Unless that's not, I don't know. Were there errors up here? No. Okay. Spring Hello World, there it is. So then this run command should be fine, right? Yeah, okay, so it started, but ah, there it is. Okay, it worked. Very cool. I don't know what was going on there. It looks like it worked. All right, cool. Consider the following Docker file. Notice that the Docker file has been split into 2 stages. First stage remains the same. The second stage is a new stage called Final. It uses a slimmer Eclipse, Tamarin, image. What's the difference? Oh, JRE. Ah, I see. Okay, so it's not the whole development kit. It's just the runtime. Continue just the Java runtime environment needed. This image provides a Java runtime environment, which is enough for running the jar file. I see. Okay. So this is like Java specific stuff, right? So we can edit our Docker file to do just that, right? So it'd be copy, run, copy, and then run the Maven, clean install, and then delete that line. From Eclipse and we'll do this as builder. Okay. And then this is an opt. Work directory is the same. Expose the port. So we're just copying the built jar files over to this final, this second stage, right? I tried using Docker in a personal project the last week. It was fun. Yeah, I feel like I'm kind of getting the hang of it. I don't know. But yeah, it's really neat because it kind of really lets you understand what the hell's going on, especially with like processes, right? Like how things are running and exactly not only how things are running, but it gives you a really good view of how your project's being built as well. Like the different components, right? And kind of a lot of control over them. So we're just copying the jar files over to this runtime, and then we're giving it an entry point to the I guess, does this just run all of the jar files? I don't know. This is just the example. So I'm just following the docs here. I'm not a Java developer or anything like that. Okay, so this is just letting us run all of those. Okay. So the first stage remains the same, yeah, basically. Okay. With multi-stage builds, a Docker build uses one base image for compilation, packaging, and unit testing, and then a separate image for application runtime. As a result, the final image is smaller in size since it doesn't contain any development or debugging tools. Ah, I see, okay. So, but then when you build it, I guess the container is only, or it used to be the image. The image is only what's actually like ready to be released, right? The built stuff. That which makes sense. Now rebuild your image. Spring hello world builder. Okay. And if we go to the images, it should be smaller, right? 428. Very cool. Then we have this running containers section, and then the Docker workshop. I don't know how much of this I'm going to do. We'll see. Ideally all of it, but I don't know. I don't want it to take forever. The screen only shows you talking. The browser and editor you're typing in are froze. Oh yeah, it's been doing that. Let me restart the. I apologize for that. Let's refresh the monitor here. There we go. Now you should be able to see what I'm doing. Okay. Yeah, for some reason I've been having that happen. It was pointed out to me yesterday as well. So thanks for letting me know. Okay, so that's good. So you should be able to see that now. Yeah, I gotta like keep an eye on that, I guess. But anyway. So. Yeah. If we go to Docker images, then we'll see that it's smaller, right? The builder is what, 428, there it is. Okay, so it's not 886 anymore. Very nice. Cool. So running containers, publishing and exposing ports. All right. So if you've been following the guide so far, you understand that containers provide isolated processes for each component. Each component runs in its own sandbox environment, completely isolated from everything else on your host machine. This isolation is great for security and managing dependencies, but also means that you can't access them directly. Okay, that makes sense. So when you publish a port with a container, it lets you, access that, right? So I'm just making sure that I'm just checking OBS now, like fervently, to make sure that this is updating. Okay. So let's do this. So yo, how's it going, Tyler? Welcome. Publishing a port provides the ability to break through a little bit of networking isolation by setting up a forwarding rule. Okay, so it's kind of like quite literally port forwarding. I mean, you can indicate the request in your host port 8080 should be forwarded to containers port 80. Okay, so that's good. Allows connection between host port and container port, which can be done via Docker run host port, container port, and then the container name. So then, for example, to publish the container port 80 to the host port 8080, the fragment command would be -p 8080 to 80, like that. Okay. Now any traffic sent to port 8080 on your host will be forwarded to port 80. Traffic on host port 8080 will be forwarded to port 80 on the container, or on the container, I guess that's fine. Ephemeral ports. Okay, I see. So at times you may want to simply publish the port, but don't care what host port is used. In those cases, you can let Docker pick for you. Okay. If no host port is provided, Docker will choose one. And by running Docker ps, you can see which host port was assigned, I guess. Publishing all ports. When creating a container image, the expose instruction is used to indicate the package application will use the specified port. These ports aren't published by default. With the capital P flag, you can automatically publish all exposed ports, which is interesting. So this is quite useful when you're trying to avoid port conflicts. Okay. To publish all ports, or all exposed ports, include the capital P tag. Okay, something like that. So in the hands-on guide, you'll learn how to publish container ports using both the CLI and Docker Compose. Okay. I think I already have that welcome to Docker, don't I? Let's just make sure that this is working. Okay, good. OBS didn't freeze on me. Let's kill this process. We don't need the spring thing anymore. Okay. Docker images. I don't think. Oh, maybe I don't actually have it. Yeah, so no Docker containers are running. 8080 to port 80, Docker / welcome to Docker. Okay. So I would assume this maybe was cached. I don't know. First 8080 refers to the host port. Second 80 refers to the container. So we can use Docker Compose. So if we go to, so we'll do make directory Docker port publishing. And then we'll do vim compose.yaml services image Docker welcome to Docker and then the ports. So this is basically just the YAML version of the command we just wrote, right? So we're mapping the host port of 8080 to the container port of 80. And then we can just do Docker compose up, right? Error response from Damon. Failed to set up a container networking driver. Failed programming external connectivity on endpoints. Oh, because the port's already allocated. So we can do Docker stop or Docker PS, and then we'll do Docker stop Docker / welcome to Docker. Wait a second. Well, what's the container called? Oh, I need the ID, the 56C thing. Okay. There we go. Now it stopped it. And then now if we try to Docker compose up, it'll work. It should. What is all this stuff here? View and enable watch, maybe? Oh. Okay, I don't know what all this stuff is. Oh, detach. Right. That's what we want. Okay, so now that should be running. Yes. Okay, very cool. So if we Docker stop AB7, and then Docker compose up again, and then can I do a -D? Ah, it does. Okay, that does work. And then there it's running again. Very nice. Cool. Very nice. All right, overriding container defaults. When a Docker container starts, it executes an application or command. Let's see, let's just make sure that we're still good. We are still going. It executes an application or command. The container gets the executable from its image configuration. Containers come with default settings that usually work well, but you can change them if needed. Let's see. For example, if you have a database container that listens on the standard port and you want to run a new instance of the same database container, then you might want to change the port settings to a new container so that doesn't conflict with the existing container. Sometimes you might want to increase the memory available, blah, blah, blah. Okay. So basically just, you know, kind of running a new container with different defaults. Docker run command offers a powerful way to override these defaults, overriding the network defaults. So that is, yeah, that's for the environment variables. We already know this stuff. You use P to map container ports to host ports. We already went through that. We already went through environment variables. Interesting. .env file acts as a convenient way to set environment variables for your Docker containers without cluttering your command line. This is actually kind of cool. So let's put that in here. So -E is to define environment variable. Env file .env will define all environment variables based on the past .env, assuming it exists and has definitions, right? Something like that would be good. Cool. Restricting the container to consume the resources. You can use the --memory, --CPU's flag with the Docker run command to restrict how much CPU and memory. For example, do you want me to turn camera off? Okay. All right, you're good.
You hungry?
Kitty cat needs to be fed, but since my girlfriend's here, I guess I put the onus on her to remember. So that's my fault. You can use the memory and CPU's flags with the Docker. Let's see. So I guess this is just what's like dedicated to the container, right?
Where's his name?
I don't remember. Oh no, I opened up a new thing this morning. It's in the fridge.
Oh, you did?
Yeah, 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 never mind. You're good. Yeah, it's in the fridge. You set a memory limit for the Python API container, preventing it from consuming excessive resources. That's pretty cool. So to prevent a container from consuming too much memory, the memory flag allows puts a cap, I should say, puts cap on the memory a container can use. Put this on like a, it's kind of gonna annoy me. There we go. And then the CPUs, okay, so similarly, you can use, just one second. You can use, what would this be? To define the max number of cores the container can use when running. Can be non-integer. Okay, I'll turn off my camera just a second. Wait, you actually learned Docker with the docs? Yup. You bet. Alright, you're good. Yeah, my girlfriend would like to remain anonymous, so I try to turn off the camera when she has to pass behind me. So, because her desk is further that way. Okay. Very cool. But yes, I do learn with the docs. You know, the old-fashioned, difficult way, right? So, all right. So this is running the Postgres image. This will actually be good practice. And then start a second Postgres container map to a different port. But that's the, okay, so that's the container port. Very cool. Okay, we're going to do that after the break, I think. So let's start the next break. I'm not going to lie, this is taking a little bit longer than I thought it would, but I mean that's a common theme with things on this channel, so you know, it is what it is. Yeah, that shouldn't be running anymore. Good. But you know, it's better to do it the right way and take longer than rush through things, right? And that honestly, like, you know, getting around, like speaking, like talking about rushing through stuff, like that is one thing that like historically I have struggled with, especially like more so when I was younger. Like when it came to learning stuff, I always wanted to like fast track and, you know, take shortcuts and stuff. But you know, if there's anything that I've learned from my CS degree, it's that you can't take shortcuts or else you're gonna fail. Because if you try to take shortcuts with the math or the you know, the proofwriting or whatever you need for one of the courses, you're gonna be sorely punished on either the midterm or the exam. So making sure you've covered all your bases is crucial, I think. So that's just another learning tip. Yo, how's it going, Dr. Cool? Welcome, welcome. Yeah, I see. The thing is I tell myself I'm gonna like finish this up off stream, but the problem is like lately I haven't really had much time off stream to work. So what am I working on? Teaching myself Docker with the docs, Docker docs, because I want to. You can read more about it on my working on Pastebin. But basically, I want to learn it so that I can start containerizing my applications within my full stack projects, pretty much. I actually transferred my working on to a paste bin because it was too long. And the Nightbot response was, I mean, YouTube chats are character limited to, I think it's like, what, 200 characters or something like that? I don't know, something dumb. Or it might be like 250, I don't remember. But there's a character limit on YouTube messages. Actually, what is the character limit? YouTube live chat. Character limit. Because I know it does have a limit, right? I guess it doesn't really say. Live chat. Okay, so there's not really. It's not even telling me. I don't even know. Because I know there's limits for like the description and the title. I know that much. But maybe it's not 100 characters or 200 characters. That maybe is a little less. Maybe it's 500. I don't know. 500 maybe makes sense. But it's something, that's for sure. And I guess YouTube doesn't want to tell us. I mean, maybe I could dig further and find it, but I don't really care enough to do that. So. Like 3/4 of it, probably. He'll go back to it. Okay, let's get started. Third session. All right, so let's get up our terminal. I'm kind of front-end developer because I'm not good at back-end. Do you have any advice? With what specifically? Like with back-end? So this is just going to run Docker run. So we're going to run 2 containers. At 5432, 5432, Postgres, and Docker run, Postgres, password. So we're going to do 2 containers, right? Then we'll do 5433 on the host. Oh, why did I do Docker dash run? That's stupid. Okay, I don't know why I did that. So we'll just modify this one. There we go. And then if we do Docker PS, we should see both running. We see this one on 5433, and then this one on 5432. Very cool. Yeah, with backend, honestly, I think if I'm being real, you kind of just have to have like interest in it to start. But if you are interested in learning and you think it'll be something you're interested in, well, of course, I just said that. You should, the way that I started was with the Odin Project. So the Odin Project does have a back-end course, right? So it's got databases and then Node.js. And this is a fairly decent introduction to back-end, I would say. The Node.js course and then the databases, which you also need as well, I would say. Because, the back-end and databases are kind of tightly coupled together. generally speaking, if you want to do anything meaningful with your backend, right? I mean, maybe you can do stuff without a database, but you know, if you're like using like local storage or something, but generally that's advised. But yeah, this is kind of how I've done my learning. I think there are other resources too, like you can use like this full stack open as well. You can do backend stuff, I think. Yeah, like this, communicating with the server, programming a server with Node.js and Express, like these sorts of lessons. Yo, how's it going, Jay? Not too much, not too much. A bit of a slow night, but it's good because I want to finish up this Docker stuff. So it's kind of weird though. The external display source in OBS has been freezing every now and again. I'm trying to like babysit it and make sure that's all right, but it's happened a couple times. So okay. So run Postgres container in a controlled network. This is something that's new. Okay. By default, containers automatically connect to a special network called a bridge network. This bridge network acts as a virtual bridge, allowing containers on the same host to communicate with each other while keeping them isolated from the outside world. Interesting. So it's kind of like a local network, like local to the machine network. Yeah, no worries, no worries, cool, no worries. You can also check out Odin here if you don't have a link. So that's what I'd recommend. But you can just skip past the front end stuff if that's already your strength, right? So okay. Here's where the custom network comes in. You create a custom network by passing a network flag. So wait, why do we want to create a custom network? Oh, because we're modifying the containers, right? Okay, so that's cool. So Docker network create test network. We'll just call it that. Docker network ls. So this should give us, okay, so this is the, here's our test network, right? Is bridge the default? Yeah, bridge. Or is it this one? I don't know. Okay, so then if we, oh, and then this is another Docker, or another Postgres image. And then it'd be network what? Would it be in quotes? Oh no, just network, my network. Okay. And then this will run I guess that didn't like it. Debug this container error. But where was the container error? Oh, because it's not my network. That's why. Thanks, this is so cool. Yeah, I appreciate it. I appreciate that you that you think it's cool. But no, Odin's a great resource. I've used it for most of my learning journey up to this point. Okay, so now this is working. Okay, so now if we do Docker PS, we should see our 5434, 33, and 32. Key difference between default bridge and custom networks. DNS resolution. Containers connected to the default bridge network can communicate with each other, but only by IP addresses. All containers without a network specified are attached to the default bridge network, which could be a risk. I see, okay. Wait, so we're just running up another one? Docker run, Postgres, memory, 512. Oh, but we're just like, we're not specifying a port, I see. Okay, so if we do Docker, so Docker stop, we'll just stop all of these. Okay. And then if we run this with the memory and the CPUs, that should be fine. And then if we do Docker PS, I guess you can't really see. Okay, so it's default to that port. You can't really see the memory usage, right? I wonder if there's like options for Docker PS. Or is it Docker container ls? Well, that's the same thing. Okay. All filter, display file sizes. Okay, so then let's see. 504 megabytes. So that's the virtual memory that we defined here, right? Something like that. Because like I'd imagine if you're running a container, you'd want to maybe know what the memory and CPUs are capped at. Presumably, right? It's kind of skimming this, by the way. How to check Docker container RAM and CPU usage. Oh, it's Docker stats. All right, so this is that Postgres. There's our assigned memory, and then our CPU percentage. And I would assume, is that a percentage of the CPU, the half core that I assigned it, or total? Percentage of the host CPU. Oh, okay, I see. So this is the host. Okay, so my host, it's like 0.01. That makes sense. Okay, so that checks out, because like I don't know how many cores this thing is, but it caps out at a half core. Like MacBook Pro M4, base model CPUs. 14 core. Okay, or no. Let's see. Because I don't even know how many cores it is. Apple 4. I think this is it. I think it's this one. Yeah, 16 gigabytes. Well, the memory down here. Oh, this is the Pro chip. Oh, wait, hold on. Apple Silicon M4 chip. I think that's what it would be, right? This is a side tangent here. I think okay, so maybe it's 10 cores. I don't know. That's fine. Doesn't really matter. I feel like they should have told us the Docker stats command, but it is what it is, I guess. Okay. And then we can also do Docker stop all. Oh, there's no all. Okay. You need to provide at least 2. Okay, so then let's do our compose.yaml. So override the default command and entry point in Docker Compose. Okay, so if we have a, let's say we have a folder, make dir Postgres test, and then cd into it, and then we'll do a vim compose.yml services Postgres Image is Postgres. Is this the latest version of Postgres? Let's see. Postgres 19 beta. Okay, so it's still, so 19 is still in beta. So I'd imagine 18 is like the stable version. Okay, that's fine. All right, entry point. Docker entry point dot sh. But I don't even think we have that shell command defined, do we? Command. So these are the flags. So for the host, it's localhost. It's not host on any sort of server. And the port exposed is 5432. Environment. So this is kind of, again, just like our Docker run, right? The background sounds so relaxed, like the keyboard ASMR things. Yeah, it is a cool keyboard. And then I also have some rain sound effects in the background, just to kind of fill in the silence, because I feel like it's kind of awkward. Well, I mean, maybe it's awkward without it, but or with it, I mean, but you know, just makes it a little, just kind of fills in that noise space a little bit. So, all right, Docker compose up. Okay, cool. So that worked. Okay, so that should. Oh, PSQL role Postgres does not exist. Oh, because that's not the role. But I don't know if this is like the version that I just had running, or if this is like the. Because the Postgres user. Because there's got to be. Like, so if we go to Docker PS here, yeah, so you can see it running, but I don't think it has. Oh, I have to enter into the container shell. My bad. I need to enter into the container shell. I forgot about that. So would it be Docker exec 1e? Wait, how do I enter the container shell? Enter container shell of running. Let's see. Oh, it's Docker run -d. Oh, Docker exec. I see. Okay. So Docker exec it, and then the 1e, and then bash. Okay, that's what we want. Okay. So we're executing that command for that container, which opens that terminal or the shell. So now I can do PSQL. That makes sense. Okay, cool. Now we're inside the container. I see. So very nice. You can also override defaults directly using the Docker run command. So if we want to like change the environment variable, this command runs a Postgres container, sets up an environment variable, password authentication, overrides the default starter commands, and configures hostname and port mapping. Yeah, but I mean, does this not create a separate? Because I mean, all of this is what we had configured inside of the. Okay, so this is actually interesting. So if we run this command, so if we do Docker PS, we see that the hash or the name is 1e, right? But then if we run this command, I bet you it's going to change. Oh, it's ready to accept connections. Oh, because I see. Okay. And then if we open up a new tab, Then if we go Docker PS, oh, it just started a new container. Oh, okay. So then what did it override exactly? Oh, or are you overriding the defaults of the image? I see. Okay, so the image comes with predefined things. I get it now. So the image comes from the registry with predefined defaults. And then this configuration is overriding it. That makes sense. Okay. I see. Okay. Persisting container data. So this is probably going to be volumes, right? Yeah. So that's good. So now I can just stop these because we're not going to use them anymore. Clear. If I could type properly. Okay. So let's do a new note to volumes. All right. When a container starts, it uses the files and configuration provided by the image. Each container is able to create, modify, and delete files, and does so without affecting other containers. When the container is deleted, the files changed are also deleted. Okay, so by default, files within containers that are deleted when the container is deleted. If you restart a database container, but do they get deleted when it stops? I guess so, because can you stop and then like start the same container again? I wonder. Or do you have to like restart it from like an image every single time? So like if you have a running container, can you like stop that container, and then can there be a container in a stopped state without it being deleted? I don't know. Docker, can a container be stopped without being deleted? Or does that delete it itself? Stop and delete Docker container if it's currently running. Yeah, so we have the Docker stop, but does that actually remove it? Docker list stopped containers. Docker ps-a. Okay. There's all of our containers. Okay. So if you just stop the container, it's still there. Okay, that makes sense. And then I think it would be like if I wanted to remove one, like if I wanted to remove Spring Hello World, for example, I could do Docker rm c4, right? And then that removes that one. And then if we do Docker ps-a again, you can see that it's gone now. Okay, so that makes sense. So, but if you just do Docker ps by default, it's only going to show the running containers. That makes a lot of sense. Okay, cool. When the container is deleted, note stopping a container does not delete it. It can be started from a stop state. Use Docker ps-a to list all containers, including stops. All right, let's see. For example, if you restart the database container, you might not want to start with an empty database. But would that not be rebuilding it, though? Because I'd assume when the container stops, the files are still there. Unless they all live in, like, memory or something, like RAM. Okay. Volumes allow for data persistence. beyond an individual container's life. Think of it like providing a shortcut inside of the container to outside the container. The data inside of a volume lives outside of the running container, or outside of the container, I should say. But the container has a link to that volume, or can have. Right? Imagine create a volume, create a new volume with Docker volume, create, and then volume. When starting a container with the following command, the volume will be mounted into the container. Mount a volume when starting a container with -v volume name / directory in volume, right? Actually be a : in that case. Am I live every day? Not quite. I'm live. I try to be live 5 days a week, Dalibor. So today I'm live, tomorrow I'm live, Monday I won't be live. You can actually, if you want to know when I'm live exactly, I release a schedule every week on usually Saturday or Sunday that kind of outlines my planned streams for the week. Sometimes they change short notice just because, you know, shit happens in life and I can't control it. But if that interests you at all, you can join the Discord. But if not, just, you know, you can turn on the notification bell or something and you'll get notified. Okay, so. But yeah, 5 days a week usually. So just dropping by to ask a question. Would you say taking notes is worthwhile? How often do you go over your notes? Congrats on 100+ consistent days, by the way. It's a huge motivator for others. Yeah, honestly, Frog, that's like what, you know, that's what I'm trying to do here is motivate others and not only to, you know, reinvigorate the passion for learning how to code and technology manually, but also just, you know, show what's possible, I guess. But yeah, for note taking, it's honestly, it's not about the notes. It's not about having the notes. It's about for me, like 75% of it is the process of taking notes, right? Like I was a student. I did 2 degrees, 2 post-secondary degrees. It's just in the process I'm just really used to. So for me, it helps me learn and kind of play with the data in my head as I'm going through it, right? Instead of just statically reading it. As for going over the notes, eventually I do go over them. Probably not as much as you like maybe would think, but I do use them on occasion, especially when you know, I take what I learned from the note taking and then apply it to a project. Oftentimes I'll go back to my notes because my notes are kind of like a condensed version of the docs of things specifically I'll want to remember when I'm building a project, right? I'll give you, here's my GitHub. But yeah, that's kind of my process, I guess. You know, and a lot of people, you know, come in here, not a lot, I should say. You know, a couple of people come in and say like, oh yeah, you know, I think writing notes is useless. You know, it doesn't help me, and that's totally fair enough. Like, because you know, AI exists obviously, and you know, the internet exists, and all these docs exist. And I don't try to like take notes to a really granular level. Like, I just try to take as much as I feel like I need to, and that's sort of something I feel out as I'm learning, right? And yeah, that's it really. So I hope that kind of addressed that. But yeah, no, I've been doing, I'm like on day, what is it, 120 something, 125, 124? I'm on day 124. Okay. Yeah, so that's 124 days, but mind you, that's over like 6 months. I have not been streaming every single day. Just for reference. So like, yeah. So like 120 days roughly is 4 months. So I've been streaming 2/3, like 2/3 of every day for the last 6 months, or 2/3 of the days in the last 6 months I streamed, which is not too bad, I would say. So, but you know, things happen. I take breaks. I take a couple days off a week just because otherwise I feel like if I streamed every day, I would burn out. The breaks are important. Also, shit happens in my life. I get sick. I have to travel. A couple months ago, I moved. These sorts of things. So sometimes I take like more extended periods off. Like I'll take a whole week or something. But yeah, generally I try not to take more than a couple days off in a row just to kind of maintain that momentum. Because at least for me, I find that pretty important to keep going. Because if I take more than a few days off, if I'm not otherwise preoccupied, I find that I get demotivated and it kind of just makes me want to quit, right? So, and I feel like that's kind of just a natural thing that a lot of us feel when it comes to doing hard things like this. So. But yeah, I also do the Pomodoro timer to kind of help not only with my focus, kind of just so I can force myself to take breaks, but also just to kind of keep track of how long I've been live for, because I like to keep the lives relatively the same length. Whether it's usually I'll do 5. My standard live is 5 Pomodoro sessions, which is 2.5 hours. So because each Pomodoro is a 25-minute work, 5-minute break, so it's half an hour, and then I usually do 5 of those. Sometimes if I'm really in a groove, like I was last night. Last night the stream like blew up. I don't know why. I'll do 6, and then other streams if I have somewhere to be, I'll do 4 or something like that. But I try to do at least 4 per stream, because otherwise I find it not worth it. So yeah. But no, I find it interesting how different streams get more traction than others, because and I feel like it's agnostic to what I'm actually doing on the stream. It's just like the YouTube algorithm just decides all of a sudden to pick up my stream sometimes and then elevate it to 3x more viewers than normal. A good resource I'd probably recommend is this one. Just by the way, Jawad, you can't post links in YouTube chat. So if you're posting a link, I can't see it, and nor can anyone else. Just as an FYI, and that's not unless you're now typing again. But I just wanted to let you know, just because yeah, it's a YouTube moderation thing. I think it's also just a good idea to turn off links in the YouTube chat, just in case someone tries to send something bad. What keeps me going with this stream? Honestly, the audience, really. The progress that I've made and the audience. Those two things. And the other thing too is I genuinely do feel like I have more of an interest in this stuff than I do a lot of things. And that interest in learning and knowing how to build projects on my own and make things is kind of what keeps me going, I guess. And the growth that I can get from that, and also the support I can give to others, because I do also like to share my process and help along the way. And I think all of that kind of combines together to motivate me. But I will say again, this is not lucrative for me. I just started. I just unlocked monetization, so I am technically making a few dollars from this, but it's nothing that I can even cash out or anything, because I don't know if any of you are creators, you would know, but YouTube doesn't let you, at least in my country, it doesn't let you it doesn't pay you until you make $100. So sure, I can make $10 here, $5 there, but I don't actually get paid until I make $100 of money. So it's kind of, so I haven't even gotten paid, right? So I'm not doing this for the money. That's definitely not. But it is, it's something that I kind of hope to eventually have as a little side income, but no, that's not the primary reason keeping me going. Just to kind of clarify that, because if it was for the money, I would have given up months and months ago. All right, let's continue forward. All right, so we have our container volumes. If the volume log data doesn't exist, Docker will automatically create it. So if you mount a volume, if the specified volume does not exist, Docker will create it. And then I wonder if you can create volumes with a fixed size. It's probably a thing that you can do. Yeah, it's I don't know. It's something. Honestly, I really didn't have many expectations going into this. The reason I started streaming in the first place was just as kind of like a journal to track my progress and hold myself accountable. And you know, I was hoping maybe to get a few viewers that would be regulars and you know, kind of hold me accountable as well. But it's kind of ballooned into something that was way more than I was initially expecting, which is fantastic, and I welcome it. But you know, I would have been happy if it was just, you know, like 10 people, like, you know, 10 people subscribed, you know, and then the occasional viewer in stream. Like that would have been enough to keep me going, I think. But no, the support and the growth is really cool. That's not to say, you know, I'm huge or anything like that. But all right, so sharing files using volumes. You can attach the same volume to multiple containers. The same volume can be used by or linked to multiple containers, allowing file sharing between containers, right? So this can be helpful for like example use cases would be log aggregation, data pipelines, how about those, event-driven applications, etc. List volumes with Docker volume ls, delete volume Docker volume rm, volume name, Docker volume prune, remove unused, unlinked. Good. Very good. All right, so let's, it keeps getting us, the thing, the running theme that I've noticed with these tutorials is that it keeps getting us starting new or building new containers, which is kind of, you know, weird, because I think I can just, if I go to like Docker, oh, you can give it a name, I see, okay. So if we go to Docker PSA, we can use one of our Postgres, right? We got a bunch of Postgres images here. So we can do like a Docker run F3 or maybe 1E, and then we define all that, and then I think we can mount a volume to it, right? So we can do a volume Postgres data just to kind of reuse the container because we have a shit ton of containers in here. Var lib Postgres. I think that'll work with the volume, right? 1E latest. Or is it Docker start? Oh, okay, so I do have to spin up a new container, I see. Okay, so Docker run builds or starts a container from an image. I see, okay. So I do actually have to do that. So Docker, can I Docker container prune? Yes. Yeah, let's just get rid of all those. Docker run name db. Postgres data, and then it was what, opt, or was it var? Okay, yeah, var lib Postgres. And then this is the image to create it off of, right? There we go. What do you want to achieve with what you're learning? The eventual goal, Superior Dev, is to, I mean, be a full stack web developer and just a versatile developer in general. I eventually would like to make a career pivot like further into the future, and so maybe for that reason, whether it's doing my own stuff, like starting my own business or whatever it is, I want to have those skills to do that, right? So like right now, currently I work in IT, which is a great, because of stability and these sorts of things, but it's not really where I see myself being in the long term, like multiple years. It pays the bills, but eventually I'd like to be kind of a versatile developer. And kind of use that for a career, whether it's getting a job, like a regular job, or working for myself, or even like doing content. I don't know. Like, is this going to turn into a job? Probably not, but I'm open to it. So who knows? Realistically. But yeah, so the goal is kind of vague, but I've always wanted to learn how to program and how to be a developer at a deep level, right? Because there's like senior developers out there that have been programming for decades, right? And that's kind of eventually, like, for my life, that's kind of what I want for myself, is to be somebody who has been programming for years and years. And I feel like, especially with AI, there's going to be less and less of those kinds of people, especially like further into the future. And maybe AI will make us all obsolete. I don't know, but that's not really, I for what it's worth, I don't think so. And I think we're kind of in this kind of multi-year hype cycle right now. Yeah, I think developers that actually know what they're doing are going to be of increasing demand as those senior developers that are older, in their 40s, 50s, 60s, retire, and all the 20-year-olds that came through during the AI wave are gonna like be screwed, right? So, like, I genuinely think like a lot of junior developers, or even like intermediate developers that have only learned in the last 4 years, 3 years, whatever it is, are kind of screwed. Like, they're very reliant on AI, and they're kind of riding the wave of AI hype to keep them secure. But that, to me, that's like not, you're not learning anything, or you're kind of skating by like heavily relying on AI as a crutch, and B, like, you're basically asking to be replaced when the AI gets to a point that it can do what you can do, right? Like, I don't know. That's just kind of my 2 cents on that piece. So I think there is value in understanding software at a deep level, even in this day and age. And again, that even goes with working with AI in an informed manner, right? Like vibe coding, right? You're working with software and you're building software, but let's say you don't really have a software background. You're beholden to the AI, right? Like, if the AI is imperfect or has a vulnerability or what have you, you're at its mercy, so to speak, right? And that to me makes me uncomfortable. I would like to work with AI as a tool that I could use for my own purposes and fully have the knowledge to drive the bus, rather than just prompt it into oblivion, right? For however good it is or not, right? So anyway, that's kind of my little rant, I guess, on that. All right, so then we'll execute that command for the database process. So if we do docker ps, you'll see that there. So that's its name. So I guess you can have multiple names too. I can have the name of this little hash here, and then it also has a name. So I can do docker exec it db psql. Okay, cool. Now we're in the Postgres. Shell, which is cool. So we can create a new table. So we can even just do we can do our to-do table, right? So we can do like a create table, or we can just do it. Table to-dos. I'm not really following what it's telling me to do, just because. So we can do ID, serial, primary key, or what was it? Postgres UU create UUID. I forget actually how to do this. Generate a UUID. in table definition. I just keep forgetting these like small little things. Because this is the function for it. Create table IUUID, primary key, default, and then we give it that generate command. Oh, and then we need to create that extension as well if this does fail. And then we'll do task text. Okay, so it does not exist. So we'll do that create extension. Create extension if not exists. UID OSSP. Nice. Cool. So now we can do select. So if we do insert into to-dos, values, you know, make supper, do the dishes, and go to sleep. I don't know. I feel like going to sleep is kind of something dumb to put on. Maybe brush teeth. So if we just do that, right? Oh, because I need to do the columns, right? Oh, I need to have them as separated things. Oh, comma separated. Okay. Now this should work. No? Oh, because the single quote, double quote thing. I remember that was a problem with the text before. Now this should work. There we go. There's our to-dos with our UUIDs. Awesome. And if we stop and quit and then run a new one, it should work, right? So Docker stop db and Docker rm db. And then if we run the exact same thing with a pointer to that exact Postgres data in that volume, and then we execute this, select all from to-dos, what's next? Maybe no semicolon? What's wrong here? IT. Oh, because it's not new DB. Right. That's what we want. There we go. Nice. So the volume persisted. That's very cool. Nice. So to view the volume contents, can I do like a Docker volume ls? So you see the Postgres data. So I wonder if we can do Postgres data. Does that work? No. Filter values. View volume contents from command line. Docker view volume contents from command line. I don't know if this is a way to do this. Ah, you can inspect. Okay, so Docker volume inspect Postgres data. I don't know what all these default volumes are. Ah, okay, so I can see var lib Docker volumes Postgres data. But I can't actually see like what's inside of it though. Again, I guess I could inside of the, you know, so if I go to that, if I go to this mount point, so if I do like, if I open up a new tab, right? So let's open up a new tab. Can I make this like this? Yes, I can. Okay. So if I go to now cd var lib docker volumes postgres data. Okay, so I guess that doesn't work. Or is that within the container? Is the mount point within the container? I don't know. Or is that on the host? I would assume it's on the host. New hosted file directory. Okay, so I guess not. Interesting. So that did not work like I thought it might. That's okay. I guess we'll just suck it up and use the desktop here. So if we go to volumes, here's our volume. Okay. So here's all the Postgres stuff, right? And then we can see which containers are using it. That's kind of cool. We can export it as well. But I want to know how to do this. Like, there's got to be a way to see the stored data inside of the command line, right? Instead of using that desktop app. Docker volume inspect commands to create and inspect volumes. Oh, okay. So you can use a temporary container and then shell into that. I see. Okay. So that's kind of annoying. Oh, because it's okay. I needed to do it as sudo. That makes sense. But that's Linux. I don't know if I could do that on Mac. Oh, it does not work for Mac OS because Docker runs inside a virtual machine. Oh, right. Okay, right. So that mount system. So let me go back. So I remember from, so if I scroll up here a little bit, I remember from last stream, somebody mentioned that on Mac OS, Docker runs in its own Linux VM, right? And so this is the mount point on that VM, not on my host machine. So the quote unquote host is the VM, I think. Docker on Mac OS, Linux VM, let's see. Virtual machine manager. I just want to see if there's like information on this. Okay, so I see. So it's using some sort of default one, right? So I installed Docker on my Mac OS. Does run a Linux host VM with a replacement for boot to Docker Linux kit developed and maintained. Okay, so then how do I like see where that's running though? I guess I would need to give it some sort of like I don't know what the VMM default is for Mac OS. Interesting. I'm not going to dig into this further, but that's kind of cool. Yeah, I use WSL3 with Windows. Nice browser. Yeah, it's just kind of nice to know like how this stuff works at a deeper level, right? So, all right. So then we can remove volumes as well. So then this -f will remove okay, so that'll remove the container, right? Because I don't think we can remove containers. Yeah, before removing a volume, it must not be attached to any containers. I should probably write that down. Okay, just making sure this isn't frozen. All right, so to remove volumes, they must not be attached to any container. And Docker volume Actually, I already wrote that. So actually I need to put this probably under here, right? Okay, that's what we want. Where's my terminal? There it is, okay. So docker rm new db. So that dash f will stop it and then remove it. And then docker volume rm postgres data. That removed it. So now if I do docker volume ls, it's not here anymore, right? Very nice. Cool. Sharing local files with containers. Okay. So each container has everything it needs to function with no reliance on any pre-installed dependencies on the host machine. Since containers run in isolation, they have minimal influence on the host and other containers. Okay, so for the sharing stuff, we were considering using volumes, which was the recommended in the previous lesson, right? Two primary storage options for persisting data. Volumes and bind mounts. Okay. Just going to include that. If you want to ensure that data generated or modified inside the container persists even after the container stops running, you would opt for volume. Okay, so let's see what a bind mount is. Do we have an introduction to bind mounts? I guess we don't really here. If you have a specific files directories in your host system that you want to directly share with your container, like configuration files or development code, then you want to use a bind mount. So bind mounts are useful when you have data on the host that you want to share with the container, e.g. config files, code, etc. It's opening direct portal between your host and container for sharing. Acts as a portal for sharing between host and container. Bind mounts are ideal for development environments where real-time file access and sharing between the host container are crucial. Okay, so this is, yeah. So that's that kind of case, right? So you would then use a volume if only sharing data between containers, but use a bind mount if containers also sharing files with host. Cool. Both -v or volume and mount flags let you share files or directories between your local machine and a Docker container. However, there are some key differences. The v flag is simpler and more convenient for basic volume or bind mount operations. If the host location doesn't exist when using the v flag, a directory will be automatically created. Imagine you're a developer working on a project. Compile or build your code that generate artifacts. Following examples of subdirectories, host, path. Now you want these build artifacts to be accessible with the Docker container running your application. Okay, so you use -v for, you can use -v for a bind mount as well. Also works with -v. Something like this. The mount flag offers more advanced features and granular control, making it suitable for complex mount scenarios. Okay. Cool. Let's take another 5-minute break. I'm hoping to finish this off in the next section here. I think we can do it, honestly. So finish this off. I'm not going to really get to the Docker workshop, but that's okay. Because we've already done a lot of this stuff. I think a lot of it's repeated, right? So I feel like getting through these concepts is just fine. So once I get through these concepts, I will I'll get back into so tomorrow I'm going to start the file uploader project that I was working on before. So if you're new here, I've been using the Odin Project generally as a rough guide to learn web dev, and I kind of hit a little bit of a roadblock here with this file uploader app. So I went back and created my own tech stack with React in the front end and Hano in the back end, and using Postgres and Drizzle to kind of learn how to create a full stack I guess project, like create my own stack for a full stack project. And then so to test that, I created a basic to-do app, which was in the last streams 115 to 122. We created that, I think, roughly, give or take. And then I want to level up a little bit and use Docker within my own stack to containerize my apps, like the front end, the back end, and the database. However, I think just for the purposes of this file uploader project, I'm just going to worry about containerizing the database, right? Because I, just to kind of ease into this sort of thing, right? Because I'm still kind of getting used to this workflow. So yeah, that's kind of that, I guess. And then we're going to finish this up. I don't know when this is going to get finished. Hopefully, within the next month, next couple weeks. And then we're going to do a bit of API stuff, testing in Express. I don't know if I'm honestly going to bother with this, or learn how to do testing in Hano instead. And then do some, maybe I'll do these projects. I don't know. We'll see. And then that'll kind of cap off the Odin project, really. The Odin project also has a getting started section, or getting hired section, I should say. Which is specifically for getting a job, which honestly at this stage doesn't really interest me, only because I feel like this guide for getting a job is a little bit dated. It doesn't really include the whole AI and shitification of the software development industry, right? How getting a job in software development is infinitely more difficult than it was 10 years ago, presumably, right? So that's the one thing with Odin Project that I'd be aware of if you are using it as a guide, is it is very aspects of it are very dated. The early concepts are good because those don't really change, like learning the fundamental HTML, CSS, JavaScript, these sorts of things, right? That's the bedrock for all of what's been built on top of web development, right? So learning those are just fine, but once you start getting into opinionated usage of tooling, Node.js, I mean, Node.js is one thing, I guess it's still kind of used, but using, for example, EJS as a templating library, right? That's kind of dated, right? That's a really dated tool. So I've kind of especially in this Node.js course, I've really taken it upon myself to expand, or not really expand, but kind of deviate from the Odin project path and teach myself more modern technologies. So yeah, I was just kind of giving that spill just for if you're new here, just but yeah, that's kind of the ultimate goal. Hopefully we finish Odin project in the next couple months. I don't know. We'll see. How is the stream doing? Let's see. kind of died a little bit, but that's okay. Yeah, I just find it so strange that like how wildly the streams vary in terms of reception, but you know what, I'm with it. All right, let's do another 25-minute session, and then after this, I'm going to probably call it for the night. Okay. So, dash mount is more complicated to use, but offers more options. Making it suitable for complex mount scenarios. By default, if you use mount, to bind mount a file that doesn't exist on the Docker host, the Docker run command doesn't automatically create it for you. Okay, so I see. So you need to actually, so like an example would be when using this, if specifying a path on the host, mount does not automatically create the directory on the host, so you have to ensure that it is defined prior, right? So file permissions for Docker to access host files. So let's do that. So when using bind mounts, it's crucial to ensure that Docker has the necessary permissions for granting read-write access. For bind mounts to work, Docker has to have read-write access to the host. Which I guess the V flag does automatically, right? During container creation. For example, the following command generates rewrite. Read-only bind mounts let the container access the mounted files on the host for reading, but can't change or delete. Okay. Read-only access to from the container, or to the host directory. The container obviously does not allow for file creation, modification, or deletion on the host, right? Just reading. I would imagine reading and copying as well. I'll just put that. Read-only bind mounts ensures that the files on the host can't be accidentally modified or deleted, which is good. In certain use cases, I would imagine. Synchronized file share. As your codebase grows larger, traditional methods of file sharing like bind mounts may become inefficient or slow. So let's see. Synchronized file shares. Improve on bind mount performance, leveraging synced file system caches, which kind of like, so instead of having to like go onto the host machine and request you know, the files from memory or whatever it is, then you can just use that cache. This is as opposed to, or I would say I would imagine this is as opposed to accessing files on the host from a container requiring reads from the SSD instead of a cache, which are slower than reading from a cache, of course. right? Something like that. All right. Start a container using the HTTPD image. I don't know what that is. Let's look it up. This Apache HTTP server is a web server application notable for playing a key role in the initial growth. Okay, so that's fine. So it's just an HTTP server then. Interesting. Okay. So let's get that open. Oh, it froze again. Of course it did. Let's fix that. There we go. I don't know how far behind that was. Pretty far, it seems like. All that note taking was missed. Okay, so that's the other thing is like, I gotta figure out why that OBS, why the external monitor keeps freezing on me. So we'll figure that out at some point. So I apologize to any VOD watchers that you can't this isn't updating. I'll look into that after stream. Okay. Docker run background with the port test site HTTPD 2.4. Okay, and then we can like check it. Okay, so there it is. That's what was returned from the server. Very cool. Navigate in the newly created public HTML, create a file. Okay, I see. Okay, we'll just do Docker RMF test site. And then we'll do make dir public HTML and CD public HTML and vim index.html. Okay, so now we just need to copy this inside and put it inside of the. Oh wait, that did not work. So I need to copy this. Oh. Okay, so it's not reading my clipboard, I guess. Control V, there we go. Okay, cool. So it's just Control V, it's not Control Shift V. Okay. The mount and V examples produce the same result. Okay. So we're going to try and mount that to this the current directory, right? When we run the container. So background name public site, and then we'll map the port, and then we'll do. So this is our host and directory, and we're currently in the directory. We want to bind mount, and then we'll mount it to the user local Apache 2 htdocs directory in the container, right? Nice. And then now if we do curl public site or localhost, sorry, we should get that Docker. There it is. Very cool. And then if we run it inside of the browser, should give us the same dealio. Oh wait, there it is. There we go. Okay, that was probably just cached from when we were testing the containers before. There we go. Nice. Cool, cool. All right. So now let's Docker stop that. So that port is exposed. Accessing the file on Docker desktop. I don't care. Cool. Stop the container. So that's good. So nice. Multi-container applications. This should get us finished, I think. And then after that, we'll finish this, and then the stream will be good. Good to go. All right. So. If I could spell properly. Just make sure that it's not frozen. Okay, looks like it's still working. That's good. Okay. Starting up a single container application is easy. Blah, blah, blah. We already did all that stuff because you can just use an image, right, to build that container or to create that container. However, as applications grow in size, managing them as individual containers becomes difficult. And I think this is really what's going to be important for us for our full stack framework, right? And that's not even a framework, but our full stack stack, I guess. Imagine the data processing Python script needs to connect to a database. Suddenly now you're managing not just the script, but also a database server, right? So this is, you don't want to do that with the same container, obviously. Useful for applications that have multiple components, example, front end, back end, database, etc., right? Do I need to run these containers separately? If I run them separately, how shall I connect them all together? Well, Docker Run is a convenient tool for launching containers. It becomes difficult to manage a growing application stack. So then this is where the Docker Compose stuff comes in. So you would have a Docker Compose. So this would be my understanding, is you'd have a Docker file inside of each, so like inside of my front end, back end database, I'd have a Docker file to define the container itself, or the image for the container, and then the Compose would kind of use those, right? I think, maybe, I don't know. I feel like this is kind of starting to come together a little bit. Imagine running several Docker run commands with different configurations for development, testing, and production environments. It's error prone and time consuming. Applications often rely on each other. Manually starting containers in a specific order and managing network connections becomes difficult. Yeah. Manually starting all needed containers with Docker run is not only time consuming, but also error prone and difficult to manage, right? Persisting data for each application requires separate volume mounts, all these sorts of things, e.g. custom settings, mounts, port exposure, etc., right? Docker Compose defines your entire multi-container application in a single YAML file. Entire multi-container applications are defined inside of a single Docker Compose YAML file, right? Don't need all the Docker runs. Can run containers in a specific order and manage networking easily. Scale individual services up or down with the multi-container setup. This allows for efficient allocation based on real-time needs. Can dynamically scale services up or down depending on demands. Can implement persistent volumes easily, and easy to set up environment variables. And I would imagine these could be also then used across different containers, right? By leveraging Docker Compose for running multi-container setups, you can build complex applications with modularity, scalability, consistency. In this hands-on guide, you'll first see how to build and run a counter web application based on Node.js, an Nginx reverse proxy, and a Redis database. I don't know what Redis database. What is this? Is this just like okay, so it's just like a Postgres sort of thing, right? So it's just a database format, I guess. Nginx node Redis. Okay, so that's going to build the images. Navigate into the Nginx, navigate into the web. So this is kind of building the images. Okay, so we're building the images manually. Okay. So this is using all of those runs, though, right? I would think. So this is showing us the way not to do it, right? We have 2 for the web. Why do we have 2 containers for the web? Sample app. I don't know why we're running 2 web containers. Nginx is typically used as a reverse proxy for web applications routing traffic to the backend servers. In this case, it routes the Node.js backend containers. Oh, I see. Okay, so depending on where it's coming from, I see. Okay, so it's kind of simulating having multiple front ends, I guess. That makes sense. Okay, so let's get started with this then. Okay. Let's clone this. Okay. And then we are going to build the images. So cd nginx and docker build -t nginx. Actually, I should probably just do docker build -t nginx and then nginx and docker build t web. Okay, so it's building the web app now, I think. Nice. Then we can run the containers using those images, right? So we have those images there. We have the Nginx image. We have the web, which is good. And then Docker network create sample app. And then Docker run -d name Redis network sample app network alias. Cool. And then that pulls Redis from the library, Docker Hub library. And then we'll run web 1 and web 2. I'm just going to copy these commands because they're basically the same idea. You're giving it the name, and then you're also giving it what was -h again? Hostname. Okay. Define hostname to run container in, I think. Is it? Or is it the hostname for the container? Yeah, container hostname. Okay, that's what I thought. Okay, good. So we're running web 1, web 2, and then the Nginx, right? And we expose 80 on 80. Oh wait, we'll do 80 80. Nice. And then we should see all of our processes running. So we see Nginx, the 2 webs, and the Redis, which is what we want. And then we can just navigate to localhost or localhost 8080. Okay, so web 1 number of visits is 1, 3, 4, 5, 6, 7, 8, 9. Cool, that's nice. So that is working. And then it's flipping between web 1 and web 2. You might have noticed that Nginx acting as reverse proxy. I'm gonna be fully real with you guys. I'm not 100% on what a reverse proxy is, but incoming time. It distributes incoming requests. I'd imagine it's a kind of layer that sits between the front end and the back end that kind of routes requests securely. That's my very, very vague understanding. Round robin fashion between the 2 backend containers. Oh, because these are 2 different backend containers. What? Oh, because the web. Okay, so this is the web server 1, web server 2. Okay, so this is being served then via a template, then, right? With like a node express, I would imagine. So if I like cd into web, right? And then let's see what's in here. So if we like vim server.js, right? So we're giving a are we doing like a templating? Redis client.get. What? I guess that's not really. Oh, this is it. Res.send, and then that's just displaying because you're. Okay, so that makes sense. You don't even need really templating for that. Cool. And then now, its output shows consecutive increments for both web 1 and web 2 containers. So the actual container value stored in Redis is updated only after a response is sent back to the client. Okay. You can use the Docker desktop dashboard to remove the containers. Oh, okay. So then we can remove the containers, right? So we can do Docker stop. Actually, Docker stop 22 or Nginx. Wait, hold on. That's the same thing, right? Container names, yeah. Docker stop Nginx, web 2, web 1, Redis, and then Docker container prune. Yes. And then we can just do Docker compose, right? So we should have our compose.yaml in here. So if we can see that here. So we have services, and then you define the ports for the web 1, web 2, and Nginx. Very nice. It's just, isn't it Q? Yeah, okay. And then we do just Docker compose up and build. So I would imagine this build is for building the images. Let's see, build. Build images before starting containers. That makes sense. That's exactly what I thought. Okay. So then this should just then work, right? Nice. And then now if we go to localhost 80, 81, there we go. But that stays on web 1. If I go to 82, then that's web 2, right? Oh wait, didn't go to 82. There we go, there's web 2. But the number of visits I think is so we have 18 visits. If I go back to 81, I think it'll stay at 18, won't it? Oh, 19. Well, it goes up by 1 because I just visited it again. But yeah, that makes sense. Cool. So I think that's everything on this, right? You know, just for deleting the containers and whatnot. So we can just do our Docker PS, and then we can do Docker stop AA779E 4A. Stop all those, and then we can just do Docker container prune. Very nice. Just to have that kind of cleared up before I, you know, use this for real. But anyway, I think I've kind of, you know, gotten a pretty decent handle on Docker over the last 2 streams. I mean, you know, I guess this would be yeah, it's the same thing. Okay. You know, I don't know. I think I have. But anyway, so that's going to do it for this stream. You know, made a lot of progress. Tomorrow we're going to be finally starting on the file uploader app. So if you want to actually see more like live development, you know, be there. It'll be exciting. If you want to follow along on my journey and you like what you see here, I really, really appreciate it. If you subscribed, it means a lot to me. And if you want to join the Discord as well, you can join the Discord for stream updates and other fun stuff. Meet fellow developers who are passionate about learning and you know, growing their knowledge, these sorts of things, expanding their knowledge, I should say. You know, but yeah, that's basically everything. See you tomorrow. Have a great night or morning or afternoon.